In this video, we will learn about velocity time, that is, speed time graphs. So, for an object traveling along a straight line, the velocity time graph tells us the variation of its velocity with time. For motion along a straight line, magnitude of velocity is equal to its speed. Hence, the velocity time graph is also referred to as speed time graph. Now, velocity, that is speed time graph for a uniform motion. For a uniform motion of an object along a straight line, the velocity of the object remains unchanged and it does not change with time. Hence, the velocity time graph is a straight line parallel to time axis. Determination of distance covered in given time. So we know that from uniform motion along a straight line, the product of velocity and time gives displacement of the moving object in that time. Now, from velocity time graph, the magnitude of displacement can easily be determined by the area enclosed by the velocity time graph and the time axis. Okay. Now, as for the motion along straight line, magnitude of displacement is equal to the distance covered by the object. Hence, the area enclosed by the velocity time graph and the time axis may also be taken as the distance covered by the moving object. Now, to find out the distance covered by an object moving with a constant velocity v between the time t1 and t2, we consider 2 points A, B on the graph corresponding to time t1 and t2 respectively. Now, when we draw normals AD and BC from the points on the time axis, we find that the distance covered in by the then the distance covered by the object between the time t2 and t1, that is t2 minus t1, would be the area of the graph. Then the distance moved by the object in time between t2 and t1 would be area of rectangle A, B, C and D. Okay. Thus we conclude that for uniform motion along a straight line, the distance covered by an object is given by area under velocity time graph, or that is speed time graph. Now, velocity time graph for uniformly accelerated motion when the object is initially at rest. So initially, if the object start moving from rest and its motion is uniformly accelerated along a straight line, then the magnitude of velocity of the object goes on increasing uniformly with time. Thus, we can say that magnitude of velocity is directly proportional to the time. Now, the velocity or speed time graph for such an accelerated motion is an inclined straight line passing through the origin. The velocity or speed time graph for uniformly accelerated motion can be used to find acceleration and the distance covered in a given time. Now, for acceleration, we can take 2 points A and B on the velocity time graph corresponding to t1 and t2 time with v1 and v2 as the velocities respectively. Now we draw a perpendicular from BC on time axis from point B, and from point A we draw a normal AG on the line BC. Now a triangle ABG is formed where BG is equal to V2 minus V1 and AG is equal to T2 minus T1. Now the change in time is T2 minus T1. So we know that acceleration is the change in velocity divided by the change in time, that is BG upon AG, right? Now the term BG upon AG is also, as we can see, is the slope of velocity time graph, right? BG upon AG is the slope. Thus, for a uniformly accelerated motion, the slope of velocity time graph gives the value of uniform acceleration of the moving object. Now, to calculate the distance, as we have seen earlier, that the distance covered during a given time is given by the area under velocity time graph of the object. Therefore, for uniformly accelerated motion as shown in the figure, the distance covered by the object in time t2 minus t1 is given as the area of ADCGB. Okay, this is a trapezium kind of figure. Now, we will simplify this by dividing it in two parts. And as we know that distance is a scalar quantity, so we can simply add these two, right? This rectangle and this triangle, because we are way more comfortable in finding the area of this. So the area of triangle ABG and the area of rectangle AGCD. Okay, that would be, for the rectangle it would be AD multiplied by AG or AD multiplied by DC. And for this triangle, the area would simply be half into base, that is AG, into height, that is BG. I hope this topic is clear to you. Thank you.